One of the most important components of a computer is its primary memory. Primary memory is a working space that the computer can store information that it's using. So the primary memory is the place that all the programs, all the instructions that make the computer work, both how it functions and the things we're trying to get it to do, like this video, they're all stored in the primary memory. It's called primary, and that means in terms of the first or the most important, because it is the part of the memory that is directly accessed and manipulated by the central processing unit, or the CPU. When we speak about primary memory, the main thing we talk about is the RAM, or the random access memory of the computer. The RAM is the main working space for the computer. When the computer is doing anything that we tell it to do, any instructions that it's been given, that's all held in the RAM. The RAM is not the only component of primary memory. There are a couple others that are less commonly associated with the term, but very important. The other main component of primary memory is the ROM, which stands for read-only memory, which means that the computer can only read information from it and not store information there. It's technically not true. ROM is usually built now out of different things that allows it to be updated when your computer needs its firmware updated. That's the ROM. But for the most part, the computer just reads the information from the ROM. The ROM is very different. If you look at the motherboard of any computer, like this Raspberry Pi, the ROM chip is much smaller than the RAM chip. And that's true of not only of its physical component, but also its storage capacity. The RAM is typically measured in billions of bytes of data, whereas the ROM will be in millions or maybe even thousands of bytes. So it's much, much smaller. Because the ROM is typically just used as startup to load up the instructions for how all the different components of the computer can be accessed. It's the firmware of the computer that controls the hardware. Besides the ROM and the RAM and separate chips, within the CPU of the computer, there's also other types of memory. There's cache memory and also registers that are part of the CPU. The cache will be either inside the CPU or right next to it, in the chip, or right very close to it. The registers are the things that the CPU is using as it does its calculations, and they're very, very small. They'll be in dozens of bits rather than in thousands or millions. The cache memory will also be smaller, but it's bigger, and the cache memory is used to hold instructions that are going to be accessed repeatedly or regularly, and it's very close to the CPU so that the CPU can get that information quickly. When we talk about primary memory, you might ask, is there secondary memory? And there's secondary memory, which is more correctly called secondary storage. Because the big difference between secondary memory or secondary storage and primary memory is that the CPU can't directly access the secondary, which is why it's called secondary. But the secondary memory can store all the information that the computer is not actively using, but will be accessing later. The biggest difference, perhaps, between secondary memory and primary memory, or secondary storage and primary memory, is that primary memory, specifically the RAM, but also the cache and the registers, is what's called volatile. That means when the power goes out on the computer, all the instructions that are stored in the volatile memory, the RAM, the registers, the cache memory, is erased. It's all zeroed. It's lost. Whereas in the secondary storage, it's non-volatile. It stores that information, so even when the power is removed from the secondary storage, then the instructions are still kept there. Modern software kind of hides that volatility from the users. When you are using a program and are writing an email or creating a presentation or something like that, that software, it's either saving copies of that to the secondary storage in the background, or if you're using a web service, it's saving that information to a secondary storage of the computer that's in the cloud that you're accessing. So that volatility gets hidden. If the power goes off, your computer shuts down quickly and you reopen it, the information's there. But really what's happening is that the software is saving a copy to the secondary storage. Some programs still function that way, where you have to manually save information to the computer, to the secondary storage. Otherwise, while you're working on it, if the power is interrupted, if the power is disconnected, if your battery fails on your laptop, you'll lose everything you're working on. The only part of primary memory that's not volatile is the ROM, because the computer needs that to start up. Primary memory is the main memory. It's the first or the most important memory that the CPU uses. Secondary storage is a subsequent thing that the CPU doesn't directly access, but is used to store information. Most primary memory is volatile. The ROM is not. ROM is still primary memory, but it's not volatile. It is retained even when the power goes off. If you found this information about primary memory interesting and useful, please like and subscribe to this channel. I'll be posting lots more information about how to conquer computer science. Also look at the description down below, and there's a link to my website, Conquer Computer Science, that has lots more information about the computer, its hardware, etc., including an online course that goes into depths about how the computer works. If you're interested, check out the links down below. Thanks for watching.